Okay, so in this video, I'm going to be talking to you about the equation of a circle and then tangents to circles. And this is a really tricky topic because it's based on a lot of other things you'll have studied so far, and you do really need to be confident in these to be successful. So some of the things you need to know about are the equations of straight lines, gradients, perpendicular gradients, surds, Pythagoras, and circle theorems. So this really is a topic that actually overlaps a lot with A-level. So if you find yourself enjoying this topic, then this is definitely a good indication that you should probably think about doing A-level maths. So let's begin by just actually talking about what the equation of a circle actually is and why it's the equation of a circle. Now in GCSE, you only have to do circles that are centered at the origin. So that means they're never going to be circles that are somewhere else on the coordinate axis. They're always going to have the center right here. Now the equation of a circle is x squared plus y squared equals r squared, where r is the radius. And actually the explanation for this is pretty straightforward actually. You'd think it might be a little bit complicated. But if we have a point that is on a circle, and this could be anywhere around the circle at all, we have that the point is a general one, x and y. And clearly by looking at this circle, the length of this black line that we've got here is r. So I'm just going to zoom in briefly on this so that we can have a look at this in a bit more detail. So the length of the black line is r that we've got here. And now what I'm going to do is I'm going to think about if we can find out how this triangle might all connect together. So I'm first of all going to say that this triangle I have got here is a right-angled triangle. And we should be able to tell what this length over here is and what this length over here is according to the coordinate p. Well, the coordinate of p is xy. It's just a general coordinate that could be anywhere on the circle. And the length of this part is the x-coordinate of p. So I can put on this part of the triangle that this is x, and then the length of this part of the triangle is just the y-coordinate of p that we have over here. So the length of this line is just going to be y. And now you can see why I said that you need to make sure you understand Pythagoras before you attempt this topic, because this triangle here connects together the radius of the circle with the x and y coordinates of the point that is on the circle by Pythagoras. X squared plus y squared equals r squared. So this is yet another application of Pythagoras' theorem. And it would work if p was in any of these other coordinates as well. You just would have either a negative for x or a negative for y, but with Pythagoras those are just going to be lengths, so when they're squared those negatives become positives and you still get this relationship holding true here as well. And obviously any point on that circle, the radius is always going to be the same, the radius is always going to be fixed. Okay, so now that we have this equation of a circle, we're actually just going to go straight in with some examples and some skills questions that we've got here. And then I'm going to give you an opportunity to do some of them with some different numbers to have a look at. Okay, so this first one that we've got here, it says find the equation of the circle center 0, 0 that passes through 2 minus 7. So this is actually just one of the points that is on the circle. So I could say that this is like my x coordinate and that this is my y coordinate right here. Well, quick reminder, the relationship is that x squared plus y squared equals r squared. Because we're trying to find the equation of the circle, this is the only thing we need to find out. What is the radius? So I can just take this x and y that I've got here and I can substitute it straight into the equation. So I'm going to have 2 squared, and then I'm going to have minus 7 squared is going to be equal to the radius squared. So that's going to be 4 plus, well, minus 7 squared is just going to be minus 7 times minus 7, which is positive 49. So the radius squared is just 4 plus 49, which is just going to be 53. So the equation of the circle is just x squared plus y squared equals 53. Now what's actually happening in this question is we've got a little diagram like this with a circle, and it says that the point it's passing through is 2 minus 7. So 2 minus 7 is somewhere over here. And what we've actually done is literally just found Pythagoras to say how long is the radius of that circle. So the only thing we would have done is square rooted to find out the radius, but we can actually just go straight in with the r squared that goes in here because of that standard form that we've got. Okay, so the second question that I've written here is to find the radius of some circles with various equations that we've got here. So remembering that the standard form is x squared plus y squared equals r squared, the radius is actually going to be the square root of these things that we've got on the right hand side. So for this first question, the radius is the square root of 100, which is obviously just going to be 10. For the second one, the radius is the square root of 12. Now, if you put that on your calculator, it will simplify that as a third, but you need to think about how you simplify these thirds. Now, 12 can be rewritten as 4 times 3, so it's the square root of 4 times the square root of 3, which is just 2 root 3. And then in this one, the radius is going to be the square root of 2a squared. Well, the square root of 2 is just going to be written as the square root of 2, and the square root of a squared is just going to be a. So we have root 2a. Just be really careful you don't put the square root sign all the way across, because that square root sign is actually just applying to the 2. If you want to write it in a different way, sometimes mathematicians write a root 2, just to make it clear that the root is only applying to the 2 and not the a there. So basically, to find the radius, you take the square root of this r squared part that we have over here. Now the third question says to draw the circle with this equation. So we can see that from the standard form, r squared is equal to 6.25. So if I want to figure out what r is, I will do the square root of 6.25, which I can just do on my calculator here. I shall do the square root of 6.25, which is 5 over 2, or that is just the same as 2.5. So usually if this was asked in like an exam style scenario, you'd be given a grid like this. You would just need to draw the circle and make sure that it has a radius of 2.5. So you'd use a compass to do that. You'd just make sure it would be going up to 2.5 here and here. It would be coming down to 2.5 here and across to minus 2.5. Sorry, I should have said minus 2.5 for these. So that you can see anywhere on this circle, the radius is going to be 2.5. If this was asked in an exam, you'd need to do an accurate drawing, so you'd need a compass, and you'd need to make sure that you set the compass so that it has a gap of 2.5 between the point and the pencil. Okay, this last one looks like it could be tricky, but it really is just an application of that same formula of x squared plus y squared equals r squared. It says, given that a circle has radius 2 root 5, centre, origin, passes through p, 3p, and p is less than 0, find the exact value of p. Okay, so this is maybe a little bit abstract to think about what's going on in this question. This is a bit harder to think about what's actually happening, but we could have a quick idea of drawing a sketch of this, because sometimes sketches help us visualize what's going on. So we're going to have a circle which is centered at the origin, and it says that it's got a radius of 2 root 5. So I know that the radius is going to be 2 root 5, and it says that p is less than 0, and we have p, 3p. So if p is less than 0, this will be negative, and this will also be negative. So I know that negative x and negative y is going to be somewhere down here. Also, the y-coordinate is 3 times the x-coordinate, so it's probably referring to a point that is somewhere down here, where it's coming p across and 3p down. And we know that the radius of this circle is 2 root 5, so that line that we've got there is 2 root 5. You don't actually need to worry about much of that at all, because you can just use the standard formula that x squared plus y squared equals the radius squared. Now the radius squared, this is the radius, 2 root 5. We're just going to carefully square that. And we also know that the x and y coordinates are p and 3p. This is the x coordinate and this is the y coordinate. So I'm going to do p squared, and then I'm going to do for the y coordinate 3p squared. Now 2 root 5, if this was a non-calculator paper, if I was going to do 2 root 5 squared, I'm actually doing 2 root 5 multiplied by 2 root 5. Well, the 2 times 2 will give me the 4, and the root 5 times the root 5 is just going to give you 5. So it's actually just 4 times 5, which is 20. So all that's left to do now is actually just solve this very simple equation. So we have p squared plus 3p squared. Well, 3p all squared is 3p multiplied by 3p, which is 9p squared. So you get p squared plus 9p squared equals 20. So that's 10p squared equals 20, meaning that p squared is equal to 20 divided by 10, which is 2. And so p is equal to either the positive or negative square root of 2, but it says in the question that p is less than 0, hence we can say, let's see if we can squeeze it in here, hence p is equal to the negative square root of 2. So actually this coordinate that we have is negative root 2 and negative 3 root 2 because of this part that we've got here. So it's really, every single question here has just repeated the same use of this formula that we've got. We're only looking at the equation of a circle here. So I have got some questions to repeat for you to do down here. Have a go at these, pause the video, and then I'm going to go through them a little bit quicker in just a second. Okay, so for question 1, it says the equation of the circle passes through 8 minus 1, and it has that standard centre there. So I can just go straight in with my x squared plus y squared equals r squared and try and find out what r squared is. So here, x and y, x is 8, so that's going to be 8 squared, and minus 1 squared is actually just the same as 1 squared, but I can still do it in brackets like this. So here we get that r squared is equal to 64 plus 1, which is 65. So that means that x squared plus y squared is equal to 65. That is the equation of that circle. Now for these ones, we're just going to find the radius. I'm going to take the square root of 36, which is just 6. I'm going to take the square root of 20, which hopefully you've worked out is the same as 2 root 5, because it's 4 times 5. And then I'm going to take the square root of 4b to the 4. Well, the square root of 4 is 2, and the square root of b to the power of 4 is b squared. So the radius of this last one is 2b squared. Now this one would probably work better if you actually had some graph paper to go with this one, but we can clearly tell that r squared in this question is equal to 2.56. So all we need to do is find out the square root of 2.56. You could put that as a fraction and work it out, or we can just go here and do the square root of 2.56, which is 1.6. So when you draw the sketch of this, you're going to need to have a circle, see if I can get it roughly in the right place, a circle that has 1.6 over here, 1.6 over here, minus 1.6 and minus 1.6, and of course that would need to be on graph paper so that it's drawn accurately. Last question, given that a circle has radius 3 root 2, centre the origin and passes through 4q and 3q, and it says that q is greater than 0, find the exact value of q. So here's my x, here's my y, and here's my r. So I'm going to go straight in with my x squared, 4q squared, plus y squared, which is 3q squared. Make sure you put the brackets so you remember to square the 4 and the 3 here, and that's equal to the radius squared, which is 3 root 2 squared. So that's 16q squared plus 9q squared equals 3 root 2 squared. So it's 3 root 2 times 3 root 2. 3 times 3 is 9, and the root 2 times the root 2 is 2. So it's 9 times 2, which is 18. So 25q squared equals 18. So q squared is 18 over 25. Last thing is just to do the square rooting. We're going to take the positive square root this time. Well, the square root of 25 is just 5, and the square root of 18 is just going to be 3 root 2. And again, you could check these things on your calculator as well, but you should have that q is equal to 3 root 2 over 5. Okay, so in the next video, we kind of step it up a bit and we start looking at tangents to circles, which really pulls in way more stuff than just this simple formula. You're going to use everything that we've got here. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.